Imagine a fishing trawler off the coast of Bornholm, hauling up its nets and finding something that should never see daylight again. A corroded canister, a hiss of gas, a burn spreading across a man's hands before anyone understands what just happened. This is not a rare accident. It has happened dozens of times since 1945, and almost every time the cause traces back to the same forgotten decision made in the chaotic months after Germany surrendered. Somewhere beneath the Baltic Sea lies one of the largest unrecovered arsenals on Earth, tens of thousands of tons of Nazi chemical weapons, sealed inside rusting shells and sunken ships, resting on the seafloor since the summer of 1945. Nobody planned to leave it there forever. But nobody had a better idea either. And what happened next would become one of the most dangerous clean-up jobs the Allies ever attempted, and one of the most quietly abandoned. By May of 1945, the war in Europe was over, but Germany's chemical arsenal was very much still real. German scientists had spent years perfecting nerve agents that the Allies did not even know existed until they captured them. Tabun, developed at the E.G. Farben plant at De Herrnfurth in Silesia, was so lethal that a few drops on exposed skin could kill within minutes. Sarin, an even more advanced nerve agent, had reached limited production by the war's final year. Alongside these newer horrors sat mountains of the older chemical stockpile, mustard gas shells left over from a doctrine that had never fully abandoned the tactics of the First War. When Allied forces swept through occupied Germany, they discovered these stockpiles scattered across dozens of factories, depots, and rail yards, far more than anyone had estimated. Some caches held tens of thousands of artillery shells. Others held bulk agents stored in drums, waiting for a war that never got to use them the way German planners intended. Historians still debate exactly why Hitler never authorized full deployment of nerve agents on the battlefield. But what is not in dispute is what the Allies now had on their hands, a captured arsenal larger and more advanced than the one they had feared for years. The Potsdam Conference in the summer of 1945 set the framework for what would happen to Germany's war machine, disarmament, demilitarization, denazification. But buried inside the practical execution of that framework was a much narrower and far more dangerous question: what do you actually do with hundreds of thousands of chemical munitions sitting inside a defeated, half-destroyed country? There was no international treaty for this. There was no established doctrine for disposing of a captured nerve agent arsenal at industrial scale. The occupying powers, Britain, the United States, and the Soviet Union, each inherited a share of the problem depending on which zone the stockpiles happened to sit in, and each was left to improvise its own answer under enormous time pressure, with limited resources and very little appetite for turning the disposal itself into a headline disaster. The factories that built these weapons were still standing, the ports were still functioning, and somebody had to decide, quickly, where millions of pounds of poison gas would go next. The British occupation zone in northern Germany held some of the largest stockpiles, concentrated around ports like Wilhelmshaven, Emden, and Cuxhaven. British officers assigned to the disposal effort quickly realized they were facing a logistics nightmare on top of a safety nightmare. Trucking the munitions to a controlled incineration site risked accidents on roads still cratered from bombing raids. Storing them indefinitely risked leaks, theft, or sabotage in a country still simmering with instability. Incineration facilities capable of safely destroying nerve agents at scale simply did not exist yet. The science of controlled chemical demilitarization was still years away from what modern disposal programs use today. Faced with an impossible timeline and almost no viable land-based alternative, British planners turned to the one option that seemed, at the time, disturbingly simple: the sea. The operation the British ran became known informally as Operation Davy Jones Locker, though at the time it carried no dramatic code name in official correspondence. just a grim administrative label attached to shipping manifests. Beginning in late 1945 and continuing through 1948, obsolete and captured vessels were loaded with chemical munitions, towed out into deep water in the Skagerrak and the Baltic Sea, and then deliberately scuttled. Some ships were packed floor to ceiling with artillery shells still containing mustard gas or tabun. Others carried loose drums of bulk agent, stacked and lashed down by dock workers who in many cases had no idea what they were actually loading. Estimates of the total tonnage dumped by British forces alone run past 100,000 tons across the operation's full run, spread between the North Sea and the Baltic, with a substantial portion concentrated in the deep basins east of Bornholm and in the Little Belt near Denmark. But that wasn't the only nation quietly filling the sea with poison. The Soviet Union, controlling its own zone in eastern Germany and administering the massive captured stockpiles near Dehern Firth and other former IG Farben production sites, ran a parallel disposal effort with even less international transparency. Soviet crews loaded chemical munitions onto barges and older vessels and scuttled them primarily in the Gotland Deep and Bornholm Basin, some of the deepest and coldest water in the entire Baltic. Because Soviet wartime and post-war documentation from this period remains only partially available even decades later, the exact tonnage the USSR dumped is harder to pin down with precision, but researchers who have studied declassified material and post-war salvage records generally place the Soviet contribution at tens of thousands of additional tons, on top of what British forces had already sent to the bottom. By the time the operations wound down in the late 1940s, the Baltic Sea had quietly become the resting place for somewhere between 40,000 and 65,000 tons of chemical warfare material, a figure that still gets refined by researchers today, with some regional estimates for specific dump zones landing closer to 32,000 tons of concentrated agent and munitions. What made this decision so shocking wasn't just the scale, it was how little anyone outside a narrow circle of military planners knew about it while it was happening. Fishing communities across Denmark, Sweden, Poland, and the newly reformed West Germany had no idea their waters had just become a chemical graveyard. Nautical charts marked the dump zones with only the vaguest warnings, sometimes none at all in the earliest years. The men loading these ships were following orders under intense secrecy, told the cargo was dangerous, but rarely told exactly what it was or why the disposal method had been chosen. And once the ships went down, there was no active monitoring program, no scheduled inspection, no long-term plan for what would happen when decades of salt water began eating through steel hulls never designed to survive underwater for half a century. Then everything changed, not with an announcement, but with the first accidents. Beginning in the 1950s and continuing in waves through every subsequent decade, Baltic fishermen began hauling up objects they could not identify: corroded canisters, oddly shaped metal blocks, lumps of solidified material that looked almost like amber when they washed ashore. Some fishermen, unaware of what they were touching, suffered chemical burns severe enough to require hospitalization. In several documented cases across Polish and German coastal towns, sailors handling recovered mustard gas residue developed blistering injuries within hours, sometimes before they even connected the substance to the object they had pulled from their nets. Word spread slowly through fishing communities long before governments issued any formal warning, a strange, whispered folk knowledge that certain patches of sea were cursed, without anyone fully understanding the chemistry behind why. For decades, official government response to these incidents ranged from muted to almost non-existent. Cold War tensions meant that Soviet dumping records were essentially inaccessible to Western researchers, while British and American records, though technically available, were scattered, incomplete, and rarely cross-referenced against actual seafloor surveys. It was not until the late 1990s and early 2000s, as environmental science matured and international bodies like HELCOM, the Baltic Marine Environment Protection Commission, began systematically mapping the dump sites using sonar and remotely operated vehicles, that the full scope of the problem started coming into focus. What they found was sobering. Entire sunken vessels still packed with intact munitions. Fields of individual shells scattered across the seafloor where hulls had disintegrated and spilled their cargo. Concentrations of arsenic-based warfare agents seeping slowly into surrounding sediment, detectable in the tissue of bottom-dwelling fish decades after the original dumping. No one expected what happened next in the scientific community, a quiet but growing alarm that the ecological risk wasn't hypothetical, it was measurable, ongoing, and in some pockets of the Baltic, actively worsening as corrosion accelerated. Marine biologists studying cod and flatfish populations near known dump sites began finding unusual tumor rates and skin lesions correlating disturbingly well with proximity to the chemical debris fields. Sediment samples pulled from the Bornholm Basin showed arsenic concentrations far above natural background levels, a direct fingerprint of the Clark compounds, the arsenic-based vomiting and blistering agents that had made up a significant portion of the older German chemical stockpile. Divers and researchers who approached the wreck sites for study had to do so under strict protective protocols, because even after 70 years underwater, some recovered shell casings still contained agent active enough to cause injury on contact. The weapons had not become inert simply because they were old. In cold, low-oxygen Baltic water, some of these compounds degrade astonishingly slowly, meaning the danger the Allies buried at sea in 1945 was, in a very real sense, still armed. The secrets most people never hear about this story go even further than the dumping itself. Very few people realize that Poland, in the decades following the discovery of contamination near its coastline, actually attempted limited recovery operations, hauling up damaged munitions for controlled destruction on land, a program fraught with its own dangers and eventually scaled back due to cost and risk. Even fewer people know that some German fishing vessels from the 1950s and 1960s carried informal, unofficial charts passed between captains, hand-marked warnings about specific patches of seafloor to avoid, knowledge that predated any government acknowledgement of the danger by years. Fewer still know that samples of tarbon recovered from Baltic wrecks became, unintentionally, some of the first post-war physical evidence Western chemists had of exactly how advanced German nerve agent production had become, information that quietly influenced early Cold War chemical weapons research on both sides of the Iron Curtain. And perhaps strangest of all, several of the scuttled vessels used in the British disposal operation were themselves former German ships, meaning the very hulls carrying the poison to its watery grave had, only months earlier, been sailing under the flag that manufactured it. What began as an emergency solution to an impossible post-war problem has become, 80 years later, a slow-motion environmental liability that no single nation fully owns and no clear plan has ever fully resolved. Modern HELCOM assessments continue to monitor the Baltic dump sites, and current recommendations largely favor a strategy of careful, ongoing monitoring rather than mass recovery, because disturbing the wrecks and sediment beds carries its own serious risk of releasing concentrated agent faster than a controlled, gradual natural degradation would. Marine engineering teams have tested small-scale removal and neutralization techniques on isolated munitions, technology that barely existed when the weapons were first dumped and that continues to improve. But a full-scale recovery of tens of thousands of tons of century-old chemical ordnance remains, by most expert assessments, more dangerous than leaving it where it rests. Fishing restrictions remain in place near the most concentrated dump zones. Trawler nets are now required in several regions to carry identification protocols for unusual objects, a direct legacy of decades of accidental discoveries by ordinary fishermen who never asked to become the first line of detection for a Cold War-era environmental hazard. The legacy of this decision reaches far beyond the Baltic itself. The post-war dumping of chemical weapons at sea was not unique to Germany's arsenal. Similar operations disposed of chemical munitions in other seas around the world in the years following both world wars, and the lessons learned, slowly and painfully, from monitoring the Baltic sites have directly shaped how modern militaries and international bodies approach chemical weapons destruction today. The Chemical Weapons Convention, which entered into force in 1997 and established rigorous, verified destruction protocols for chemical arsenals worldwide, exists in part because of hard lessons drawn from exactly this kind of post-war improvisation. A reminder that disposing of a weapon safely is every bit as difficult as building it in the first place, and in many ways, considerably harder to undo. Standing on a quiet Baltic shoreline today, it is almost impossible to imagine what lies beneath the calm surface a few miles out. Rusting hulls, scattered shells, chemistry designed to kill still technically capable of doing so, resting exactly where a group of exhausted, overwhelmed officers decided to leave it 80 years ago, because no better answer existed at the time. It raises an uncomfortable question that reaches well past 1945, when a weapon becomes too dangerous to keep and too dangerous to destroy. Who actually decides what happens next, and how many of those decisions are we still living with today without even realizing it? If this story pulled you in, there is another one waiting. Another decision made in the chaos after the war that quietly shaped the world we live in now. And it involves an entire fleet of aircraft nobody expected to survive the peace. Subscribe so you do not miss it, and let me know in the comments which forgotten post-war decision you want uncovered next.